Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about the mean value theorem.
Minute Math, when you need help you use Minute Math.
I'm given this problem right here, y equals a negative x squared plus 8x minus 17, and we define the value of c that satisfies the mean value theorem on the interval from 3 to 6. Now, I found for you here, we first need to find what f of 3 and f of 6 are. So we have f of 3 here is equal to, and I found out for you, is a negative 2. Plug it into our equation. And f of 6 is a negative 5. From there, we have to use the mean value theorem to find our value of c. So we take the derivative of our function. All right, so we can do that right here. Our derivative, negative 2x. I almost messed up the derivative right from the beginning. Not good. Power rule, negative 2x plus 8, and that's our derivative. We set that equal to, using our formula here, f prime, or f of b, let's call negative 5, minus a negative 2 over b minus a, 6 minus 3. Okay? From there, we need to simplify this. We have negative 2x plus 8. And negative 5 minus a negative 2 is like plus a positive 2. And we're subtracting 6 minus 3. And so this comes out to be a negative 3 over a 3. So negative 2x here plus 8 equals negative 3 over 3, which is a negative 1. And we're solving for x. Subtracting 8 to both sides, pretty easy here. And negative 2x equals a negative 9. Divide both sides by a negative 2. And x equals a positive 9/2. And so we need to find our value for c. Now 9/2 is within our range here in a sense, or interval from 3 to 6. And so our c value here is just 9/2. And that is a value of c that satisfies the mean value theorem. We're given this problem right here, y equals x to the third power minus 9x squared plus 24x minus 18, and we define the values of c that satisfy the mean value theorem over an interval from 2 to 4. Now the mean value theorem tells us we need to find f of 2 and f of 4. We need to find those values. So f of 2, and I found that for you, f of 2, plug it into our function here, is just a 2, and the f of 4 is a negative 2. Now that we have those values, we can apply our mean value theorem. We take the derivative of our function, 3x squared, minus 9 times 2 is 18x, plus a 24. And there's our derivative. We set it equal to, using our formula, f of b, negative 2, minus f of a, 2, all over b minus a, 4 minus 2. From there, we need to now simplify this. So we have 3x squared minus 18x plus 24. And that's equal to, well, negative 2 minus 2 is a negative 4 over 4 minus 2, which is a 2. From there, 3x squared minus 18x plus 24 is equal to negative 4 divided by 2 is a negative 2. Now we're solving for x here, so we're going to add a 2 to both sides. And we have 3x squared minus 18x plus a 26. And that's equal to 0. From here, we're going to have to use the quadratic formula. So setting that up, x equals a negative b, negative 18, plus or minus the square root of negative 18 squared, minus 4 times our a value, which is 3, times our c value, which is 26. All over 2 times a, 2 times 3. Now hopefully you know how to use a quadratic formula, but I simplify this out some for you. Negative makes a positive 18, plus or minus the square root, and the inside comes out to be a 12. All over 2 times 3 is 6. This simplifies to be x equals a 9 plus or minus square root of 3 over 3. And both of these values are the 9 plus square root of 3 over 3, and 9 minus square root of 3 over 3 is within our interval. So our two c values we can label here is 9 plus square root of 3 over 3, and 9 minus the square root of 3 over 3. And these are the two c values that satisfy the mean value theorem. We're given this problem right here. Y equals a negative x squared over 2 plus x minus 1/2. And we have to find the values of c that satisfy the mean value theorem on the interval from -2 to 1. Now, we first want to, when we're applying our mean value theorem, we have to find what f of -2 is and f of 1. Now I found these values for you. We plug -2 in for x here, and we have a -4.5. Plug a 1 into our function here, and we get a 0. So now we have all the pieces, kind of all the pieces for the mean value theorem. We need to apply or find the derivative of our function. So the derivative here, power rule, 2 comes down, but we divide that by 2 right here, so we have a negative x left over, plus the derivative of x is 1, and derivative of the constant is 0. Don't need to write that. That is equal to, let's apply the mean value theorem, f of b minus f of a. So let's go, which one first? A -4.5, really doesn't matter, minus 0 over, just keep the x values in line as well, -2 minus 1, and now we can solve for x. Keep negative x plus 1 here. The right hand side simplifies to be a -4.5 over a -3. Keep going, negative x plus 1 equals -4.5 divided by 3 is a 3/2. Subtract 1 to both sides, and negative x equals a 1/2. Divide both sides by a -1, and we have x equals a -1/2 here. Well, we only have one value c that is within our interval. We're good, and so our c value here is just a -1/2. And this -1/2 is the c value that satisfies the mean value theorem. I'm given this problem right here. Y equals x squared over 2 minus 2x minus 1. And we have to find the values of c that satisfy the mean value theorem from -1 to 1. Well, we want to find our f of -1 and our f of a +1. And so we plug those values into our function that's given here, and I have the values for you. And we have a 1.5 and a -2.5 here. So f of -1 is a 1.5, and f of a +1 is a -2.5. Now to apply the mean value theorem, we also need to take the derivative of our function. In doing so, power rule 2 comes down, cancels out with that 2 in the denominator, and we just have an x. Derivative of 2x is a 2, so we subtract a 2, and the constant is just 0. We set it equal to our f of b minus f of a, so -2.5, which we found, minus a 1.5, over b minus a, 1 minus a -1. Pretty simple so far. X minus 2 here, simplify the right hand side, and -2.5 minus a 1.5 is a -4. I can't add. I almost said 3.5 there. -4 over 1 minus a negative plus a +2. So x minus 2 equals a -2 here. Add a 2 to both sides, and x equals 0. And 0 is within the interval from -1 to 1, and so our c value is equal to 0. And that c value equal to 0 is the c value that satisfies the mean value theorem. We're given this problem right here. Y equals x to the third power plus 3x squared minus 2. And we want to find the values of c that satisfy the mean value theorem from -2 to 0. Now, part of the mean value theorem states that we need to find f of -2 and f of 0. And we're plugging that into our original function here. Well, I found these values for you, and f of -2 is a +2, and f of a 0 is a -2. Okay? Now from here, what we want to do is we're going to find the derivative of our function, and we're going to apply our mean value theorem. So, derivative of x to the third is 3x squared, plus 2 times 3 is 6x, and then the 2 goes away. We set that equal to our little formula. F of b, -2, minus f of a, 2, all over b minus a, 0 minus a -2. Bringing everything together here, 3x squared comes down, plus a 6x, and the right hand side is, well, -2 minus 2 divided by, well, it's like plus a -2, right? And plus a +2. So -4 divided by 2 is a -2. Add a 2 to both sides, and we have 3x squared plus 6x is plus 2 is equal to 0. From there, what we want to do is, well, we need to apply our quadratic formula here. Okay, so by applying the quadratic formula to solve for x, if you remember it, we have x equals a negative b6 plus or minus the square root of 6 squared minus 4 times our a value 3, c value which is 2, all over 2 times a, which is 3. Well, this simplifies here to be x equals a negative 6 plus or minus the square root, and the inside comes out to be a 12, all over 2 times 3, which is 6. And this simplifies to be a negative 3 plus or minus the square root of 3 over 3. Now, both of these values here for x are within our interval from negative 2 to 0. And so what we have here, we say our c value is equal to, write it separately here, negative 3 plus the square root of 3 over 3, and a negative 3 minus the square root of 3 over 3. And these are the two c values of our function that satisfy the mean value theorem. We're given this problem right here. Y equals a negative x to the third power plus 4x squared minus 3. And we define the values of c that satisfy the mean value theorem on our interval from 0 to 4. First thing we want to find is f of 0 and f of 4. Now remember, we're plugging that into our original function. I found these values for you, and f of 0 is a negative 3, and f of 4 is also a negative 3. Now the mean value theorem also tells us we need to take the derivative of our function here. Power rule comes down, we have minus 3x squared, plus 2 times 4 is an 8x. We set that equal to, using our formula, f of b minus f of a. We found that negative 3 minus a negative 3, all over b minus a, 4 minus 0. Let's go simplify this out here. We have a negative 3x squared plus 8x, and well, minus a negative 3 is plus a positive, but then we get a 0, right? Negative 3 plus 3 is a 0, divided by anything is 0, so we have 0 here. Well, we want to solve for x, so if we pull out an x here, we have x times a negative 3x plus 8 equals 0. Set each one individually equal to 0. X equals 0, and negative 3x plus 8 equals 0. Subtract the 8 to both sides, divided by a negative 3, and x equals a positive 8/3. So we have two x values here, but only one of them is actually our c value. Now which one is that? Well, 0 has an issue. 0 is an endpoint of our interval, and they say here with a parenthesis from a to b on that interval. And so 0 actually falls just outside of that interval, we cannot use it. 8/3 is the only one we can use. So a c value of 8/3 is the value of c that satisfies the mean value theorem. I'm given this problem right here. Y equals x squared minus 9 over 3x, and we want to find the value of c that satisfies the mean value theorem on our interval from 1 to 4. Well, first thing I want to find is what is my f of 1 and my f of 4. We're plugging those values in for x of our original function right here, and I found them for you. F of 1 is a negative 8/3, and f of 4 is 7/12. Okay? From there, what we want to do is find our derivative of our function. So, the derivative of function using the quotient rule, derivative of the numerator is a 2x, times the denominator, 3x, minus derivative of denominator, 3, times the numerator, x squared minus 9, all over denominator, 3x, all squared. And then we set that equal to f of b minus f of a, so 7/12 minus a negative 8/3 over b minus a, 4 minus 1. Alright, so now let's go simplify where we can. 2x times 3x is a 6x squared, minus 3 times x is 3x, or 3 times x squared is 3x squared, but keep the minus sign going. Minus 3 times negative 9 is a positive 27. All over denominator 3x squared is a 3x all squared is a 9x squared. What is that equal to? Well, I simplified all this for you. Practice your fractions if you need it. And that's a 13/12. At this point, I simplify actually this a little bit. 6x squared minus 3x squared is a 3x squared plus 27 almost got ahead of myself here, and 9x squared, and that's equal to 13 over 12. So now at this point, I'm going to cross multiply 12 times the 3x squared plus 27. So 12 times 3x squared is a 36x squared, and 12 times a 27 is a 324. 9x squared times 13 is 117x squared. All right. From here now, we're solving for x, okay? I'm going to subtract the 36 to both sides, 36x squared, and I have 324 is equal to an 81x squared. Divide both sides by 81, and I have a 4 equals x squared. Take a square root of both sides, and x equals a plus or minus the square root of 4, which is a 2. Now we have two values. We have a positive and negative 2. So we can write like this, positive 2 and a negative 2. Only one of them is within our interval, and that's a positive 2. Negative 2 is outside the interval. And so we can't use a negative 2, only the positive 2. And so our c value of being 2 is the value of c that satisfies the mean value theorem. I'm given this problem right here. Y equals x squared over 2x minus 4. And we want to find the values of c that satisfy the mean value theorem on our interval from negative 4 to 1. Now, we want to find our f of negative 4 and our f of 1. We plug them into our original function, and I found them for you. Negative 4 in for x gets us a negative 4/3. 1 in for x gets us a negative 1/2. Okay. We have those two values now. So now we're going to start working with the mean value theorem. We need to take the derivative. So derivative of our function, okay, derivative of x squared is a 2x times the denominator, 2x minus 4, we're using the quotient rule here, minus derivative of the denominator, which is 2, times the numerator, which is x squared. All over denominator, 2x minus 4, all squared. We set that equal to f of b minus f of a, so negative 1/2, minus a negative 4/3, all over b minus a, 1 minus a negative 4. So left-hand side, let's go simplify this. 2x times 2x is a 4x squared, and 2x times a minus 4 is a minus an 8x. And then 2 times x squared is a minus 2x squared. All over, the denominator simplifies out. We have 2x minus 4 times itself, so we have 4x squared here, minus a 16x plus a 16, almost said minus there, plus 16, is equal to, and this whole right-hand side here, we have plus a positive, either way, that simplifies to be a 1/6. From there, let's go simplify this left-hand side a little bit more. 4x squared minus a 2x squared is a 2x squared. So we have 2x squared here, minus 8x over 4x squared minus 16x plus 16 equals 1/6. And now here is where I decide to cross multiply. I multiply the 6 up here, right, like this. And then this function, 6 times the 2x squared minus 8x, and then 4x squared minus 16x plus 16 times the 1. 6 times 2x squared is a 12x squared, and then 6 times a minus 8x is a minus 48x. That is equal to, let's rewrite basically the denominator, 4x squared minus 16x plus 16. Now for here we go combine our like terms. So I'm going to subtract everything over. So minus the 4x from the 12x squared, or 4x squared, 12x squared is an 8x squared here. Add a 16x to both sides, and I have a minus 32x now. And then subtract a 16 over here. Equals 0. 8 goes into all parts here. Divide everything by 8, and I have 8 in each thing. So I have x squared minus a 4x minus 2 equals 0. So now from here, we want to apply, well, we have to use the quadratic formula here. So setting it up, we have x equals a negative, a b value, which is a negative 4, plus or minus the square root, negative 4 squared minus 4 times our a value, which is 1, and our c value, negative 2. All over 2 times our a value, 1. This simplifies all out to be x equals, we have a 2 minus square root of 6 and 2 plus square root of 6. And so only one of these is actually in our domain from -4 to 1, our interval there. And that is in 2 minus square root of 6. 2 plus square root of 6 is outside clearly. 2, right, is bigger than 1, right? So we have 2 minus square root of 6. And so the c value here, the only one that we can use, is equal to 2 minus square root of 6. And that is the c value that satisfies the mean value theorem. I'm given this problem right here. Y equals a negative 2x plus 6 to the 1/2 power, and we want to find the value of c that satisfies the mean value theorem on our interval from -2 to 3. First thing I want to find is my f of -2 and my f of 3. I'm plugging those into my original function here, and I got the value for you. F of -2 is a negative square root of 10, and f of 3 is a 0. From there, we want to find the derivative of our function. So we're finding the derivative of our function here. We have the negative stays up front, 1/2 comes down. Inside stays the same, -2x plus 6. Subtract the exponent by 1, -1/2. Multiply that by the derivative of the inside, it's a -2. We set that derivative equal to our f of b minus f of a, which in this case is 0 minus a negative square root of 10, over b minus a, 3 minus a -2. From there, we try to simplify the left-hand side. Negatives cancel and become a positive. 1/2 and the 2 cancel each other out. Well, 1 in the numerator, this whole -2x plus 6 to the -1/2 power could be a positive 1/2 power in the denominator, which is a square root. And so we have the square root here of -2x plus 6 in the denominator. The right-hand side simplifies, well, the negatives cancel out here. Negative makes positive. So we square root of 10 over again, positive, 5. Now here's where I like to cross multiply. As such, 1 times 5 is a 5. And that's equal to, well, square root of -2x plus 6 times the square root of 10 is that we can, since multiplication, we can combine them to be one square root. Square root of 10 times a -2x plus 6. Okay. Well, what does that simplify really to be? Well, we have a 5 here equals the square root. 10 times -2x is a -20x. And then 10 times 6 is 60. If we now square both sides of the equation, what do we get? Well, 5 squared is a 25. On the right-hand side, well, we eliminate the square root. So we have a -20x plus 60. And now we're just solving, well, for x like we normally do. Okay, so I subtracted 60 to both sides, and 25 minus 60, almost lost my spot here, is 35 equals a -20x. Divided both sides by -20, and x is now by itself, and it's a positive 7/4. 7/4 is within our interval, so we're good there, so our c value is equal to 7/4. And this c value that equals 7/4 is the c value that satisfies the mean value theorem. I'm giving this problem right here. Y equals a negative, and in parentheses now, -5x plus 25, all to the 1/2 power. And we want to find the values of c that satisfy the mean value theorem on our interval from 3 to 5. We first want to find what is f of 3 and what is f of 5. And we're plugging those values into our function, original function, right here. I found them for you. F of 3 is a negative square root of 10, and f of 5 is a 0. So now from here, what we want to do is we want to find the derivative of our function. Negative stays up front, 1/2 comes down, using the chain rule here, keep the inside the same. 5x plus 25, and then power rule, 1/2 minus 1 is a -1/2. Multiply that by the derivative of the inside, which is a -5. We're setting that equal to, using our formula over here, f of b minus f of a. So 0 minus a negative square root of 10 over 5 minus the 3. Now let's simplify the left-hand side here. The negatives cancel, becomes a positive. We have 5 left in the numerator, and the denominator brings this 2 down right here, 2. And then the -1/2 power is a positive 1/2 power when it's in the denominator, which is also equal to the square root. So we have 2 times the square root of negative 5x plus 25. And what is that equal to? Well, 0 minus a negative square root of 10, it's like plus a positive. So we square root of 10 here over 2. 5 minus 3 is 2. Oh my goodness. I was like thrown off. Again, I keep looking at different parts of my notes. Woof. Anyway, now what I want to do is I want to cross multiply here and see if we can simplify. 5 times 2 is a 10. And that's equal to, multiply 2 up here, if we have 2, times the square root. Now we can combine the 2 square roots together, right, into one big square root with multiplication. So 10 times the inside, negative 5x plus 25. I'm going to divide both sides by 2, kind of bring it back over there, and we have 5 equals the square root of 10 times negative 5x is a negative 50x plus 10 times 25 is 250. From there, I'm going to square both sides of the equation to get rid of that square root. That work shown over here, 5 squared is a 25, is equal to negative 50x plus 250. Now again, we keep solving for x here. I subtract the 250 to both sides, and I have a negative 225 equals a negative 50x. Divide both sides by negative 50, and that simplifies to be x equals a 9/2. 9/2 is within our interval here from 3 to 5, and so our c value is equal to 9/2. Oops, I almost wrote fifths. 9/2 here, Sean. 9/2. So c value is 9/2, and that is the c value that satisfies our mean value theorem. We're given this problem right here. Y equals a negative x squared over 4x plus 8, and we're going to determine if we can do the mean value theorem on our interval from negative 3 to negative 1, and if we can, find the values of c that satisfy this theorem. Now, the theorem tells us that we have to be continuous on our interval from negative 3 to negative 1. Now, I see we have a rational function here, and we know we can't divide by 0. It's not going to be continuous there. So we take our denominator, 4x plus 8, and set it equal to 0. Well, subtract 8 to both sides, and 4x equals a negative 8. Divide both sides by 4, and x equals a negative 2. And so negative 2 is where, if we plug it in for x here, will be divided by 0. Well, that's within our interval here. Negative 2 is within the interval, meaning during that interval we have a place where we're dividing by 0 where it's not continuous. And so this function actually cannot use the mean value theorem. We would say the function, to state how, the function, I can't spell, function, the function is not continuous on our interval, which is negative 3 to negative 1. And so again, our final answer here is the function is not continuous on negative 3 to negative 1. We're given this problem right here. Y equals a negative x squared plus 9 over 4x. And we want to find if we can use the mean value theorem on our interval from 1 to 3, and if we can, find the values of c that satisfy this theorem. Well, the main thing is it continuous and differentiable? Well, it's continuous everywhere in the rational function except where it's dividing by 0. And that occurs when 4x is equal to 0 and x equals 0. So at x equals 0, we have an issue where it's not continuous and not differentiable there, but luckily for us, that is not within our interval, so we are fine. So we can apply the mean value theorem. We want to find what is our f of 1 and our f of 3. Well, luckily I found that for you, and f of 1 is a 2, and f of 3 is a 0. So now the mean value theorem states that we need to take the derivative of our function. Using the quotient rule, derivative numerator is a negative 2x times the denominator, 4x, minus the derivative of the denominator, which is a 4, times the numerator, a negative x squared plus 9, all over our denominator, 4x squared. From there, we set that equal to f of b minus f of a, which is a 0 minus a 2, over a b minus a, 3 minus a 1. Now it's time to simplify and solve. Negative 2x times a 4x is a negative 8x squared. minus the 4 times a minus x squared is a positive 4x squared, minus 4 times a positive 9 is a minus 36 here, all over 4x squared, which is 16x squared. The right-hand side simplifies to be just a negative 1. Now what we're going to do is simplify a little more here. Negative 8x squared and 4x squared is a negative 4x squared, if I can count, minus 36, and that's over a 16x squared equal negative 1. From there, I'm going to multiply both sides by 16x squared. I'll do it up here. And we have a negative 4x squared minus 36 is equal to the negative times the 16x squared, which is a negative 16x squared. So now let's go solve for x. I'm going to add a 16x squared and 6 to both sides. And 16x squared plus a negative 4x squared is a positive 12x squared minus 36 equals 0. Subtract or add 36 to both sides, and we have 12x squared equals to 36. Divide both sides by 12, and x squared is equal to 36 divided by 12, which is a 3. We then take the square root of both sides, and we have x equals a positive square root of 3 and a negative square root of 3. Okay, so we have a positive square root of 3 and a negative square root of 3. A negative square root of 3 is outside of our interval from 1 to 3. So we can't use that. So we can only use square root of 3, which is inside of our interval. And so our c value is equal to the square root of 3. And that c value equal to the square root of 3 is the value of c that satisfies the mean value theorem. I'm given this problem right here, y equals a negative 6x plus 24 all to the 2/3 power, and we have to determine if we can find the mean value theorem, and if we can, we have to find the value c that satisfies it on the interval from negative 4 to negative 1. Well, the first thing is our function continuous, and yes, we have a third root of a function here, but it's going to be continuous everywhere. The issue is going to be differentiability. That where it's not differentiable, it's going to happen when we take the third root becomes a 0. It has like a cusp there, a point, if you will. Well, that happens if we put a negative 4 in for x here, right? Negative 4 in for x. 6 times negative 4 is a negative 24, plus 24 is a 0. And so at negative 4, when x equals a negative 4, we have an issue. But it has to be differentiable on our interval from a to b, include the parentheses there. So it happens at negative 4, but right inside we're fine. So we're differentiable within the interval that we need. So we can apply the mean value theorem here. Now we want to find what is our f of negative 4 and our f of a negative 1. I found these values for you, and f of negative 4, when plugged into our function here, is a 0. But the f of a negative 1 is a negative third root of 324. Now let's not be afraid of the weird numbers here. Mean value theorem states that we need to take the derivative. So the derivative of our function here, negative stays out front, power rule 2/3 comes down, keeps the inside here, 6x plus 24. Subtract the exponent by 1, and we have a negative 1/3 here. Multiply that by the derivative of the inside using the chain rule, and that's 6, just 6. That is equal to, our f of b minus f of a, so negative third root of 324 minus 0 over b minus a, negative 1 minus a negative 4. So let's go simplify this left-hand side here. Okay, the 3 and the 6 cancel out, and that becomes a 2. Negative 2 times 2 is a negative 4. Now our denominator here, we have that 6x plus 24 goes down. We have a positive 1/3 power now, which is the same as the third root. So we have the third root here, if I can write third root, of 6x plus 24. And that's equal to the right-hand side, which simplifies to be a negative third root, of 324 over denominator, which is a positive 3. And so at this point, I like to cross multiply here. 3 times the negative 4 is a negative, oh, that's what I did. I brought the negative down the denominator here, but it doesn't matter, but when we cancel it out, we have a positive 12 here. Okay? Now, square root of 3, third root of 6x plus 24, and third root of 324, we can write as one big third root, and we have 324 multiplied by 6x plus 24. We're going to simplify this. I'll put them over here. So, all this simplification going on here. Okay, and I think I skipped a step here. Oh, no, I didn't. All right. I'm going to take the third power of both sides to get rid of that third root. So, 12 to the third power is a 1728, and that's equal to 324 times that 6x plus 24. All right. I'm going to distribute the 324 to both parts here. So I have 1728 is equal to 324 times 6x, large numbers, 1944x, plus 324 times 24 is a 7,776. A lot of sevens there. All right, but even though it's large numbers, same process applies. Solve for x. Subtract the 7,776 to both sides. I have a negative 6,048. That's equal to 1944x. Divide both sides by 1944, and x is by itself in a simplified fraction form of negative 28 over 9. Now, negative 28 over 9 is within our interval here of negative 4 to negative 1, and so our c value is negative 28 over 9, and the c value is the c value that satisfies the mean value theorem. I'm given this problem right here, y equals an x minus 3 all to the 2/3 power, and the interval from 1 to 4, and we determine if we can use the mean value theorem, and if we can, we define the values of c to satisfy this theorem. Now, luckily for us, our function is, the way the third root's function here is continuous everywhere. The issue is going to be where it's differentiable. It is differentiable everywhere except for where we have a 0 and we're taking the third root of 0 there. So that happens when, well, let's find that. We have this inside here, x minus 3 is equal to 0. Add 3 both sides, and x equals 3. So at x equals 3, we're not differentiable there because we have like a little cusp. If we graph that, we have 3. Our graph, our function looks something like this. And you can see right there, it's continuous everywhere. Well, it kind of keeps going up, but whatever. But it's not differentiable at that cusp there at 3. Now we have an issue though. That 3 is within our interval from a to b, 1 to 4. And so our function is not differentiable there. That means we cannot apply the mean value theorem. So the reason here is the function, or our statement here, the function is not differentiable on our interval from 1 to 4. And notice again the parentheses there, because it's the interval from 1 to 4 with the parentheses. So again, our final answer here is the function is not differentiable on our interval from parentheses 1 to 4. We're given this critical thinking question. Use the mean value theorem to prove that absolute value of sine of a minus sine of b is less than or equal to the absolute value a minus b for all real values of a and b where a is not equal to b. Well, let's start off this by saying let's let f of x equal to the sine of x. Okay, we have a function there. And we're going to use the interval from a to b. Okay? Well, what do we know about the MVT, mean value theorem? We know by the MVT that there is at least one c value, so at least one c value such that, let's apply the mean value theorem here. Mean value theorem states that our f of b minus f of a, okay, so f of b minus f of a, so that would be the sine of b minus the sine of a over b minus a is equal to the derivative of our function sine of x, which is cosine at our value c, so cosine of our c value. Okay, so we have that written out here using the mean value theorem. Derivative of sine, cosine, we're finding it at c. Well, what do we know about, well, our c value then, the cosine of c? Well, we know the cosine of c has to be less than or equal to 1 for all c. We know that because remember how cosine, right, oscillates, right? It kind of does the like that, right? And it's between a 1 and -1. But the cosine of c has to be less than less than or equal to 1 for all values of c. Okay. So what do we know here then? Then we know that cosine of c here, right? We can replace that to be with the sine of b minus the sine of a over b minus a is less than or equal to 1. Well, from there, we know, okay, that the absolute value, right, from there, that if we take the absolute value of everything, we can flip it around with the absolute value of sine of a minus the sine of b over a absolute value of a minus b here is less than or equal to 1. And so if we multiply that a minus b absolute value to both sides, we have the absolute value of sine of a minus sine of b is less than or equal to, if I can fit it in here, absolute value of a minus b here, and there we have it. We have what we were trying to look for here, and we've shown now how or proven using the mean value theorem that absolute value of sine of a minus sine of b is less than or equal to absolute value of a minus b for all the real values of a and b where a is not equal to b, and that is our final answer. I hope this video was helpful for you. If it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you, for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.